At this year's DSEI exhibition in London, Finnish defence company Patria drew significant attention with the unveiling of its latest innovation, the TrackX next-generation multi-role tracked vehicle. The debut marked one of the most talked-about moments of the show, as many observers described the platform as a long-awaited breakthrough in a category that has seen little change for decades. The TrackX was created within the multinational FAMOUS program, which aims to deliver modern solutions for mobility in demanding terrain. Unlike heavy infantry fighting vehicles, TrackX is designed as a lightweight, versatile carrier, capable of fulfilling multiple roles, from troop transport to command, medical evacuation, and engineering missions. In its baseline armored personnel carrier configuration, it carries a crew of 2 + 10 soldiers. Technically, the vehicle combines agility with reliability. It weighs just 15.5 tons, offering low ground pressure that allows it to move across swamps, snow, forests, and mud, terrains where heavier IFVs would struggle. SUSI composite rubber tracks, paired with hydropneumatic suspension, provide both mobility and comfort. A 269 kilowatt engine gives it a road speed of up to 80 km per hour and an impressive operational range of 500 km. Importantly for Northern Europe, the vehicle is amphibious by design, with a swim speed of 4 km per hour and minimal preparation required. Protection follows NATO's STANAG 4569 standards. The basic version offers Level 1 ballistic and mine protection, but modular upgrades are available. At DSEI, Patria demonstrated TrackX fitted with a heavy machine gun mount, a secondary weapon, and even a drone jammer, a clear nod to today's hybrid warfare environment. From an analytical perspective, the TrackX fills a crucial niche. It is not intended to replace heavily armed IFVs like the CV-90 or ASCOD, but rather to provide an affordable, flexible, and highly mobile platform for operations in extreme conditions. With a projected mass production date of 2027, it could become an attractive option for NATO and EU partners seeking to modernize their aging M113 or MTLB fleets without the high costs of heavy armor. The timing of its introduction is also strategic. The war in Ukraine has demonstrated how essential mobility and adaptability are in modern conflict, particularly in terrain that is hostile to heavy vehicles and in scenarios where drones and mines pose constant threats. By presenting TrackX now, Patria is offering not only a product but also a vision of how European land forces might evolve in the near future. For Finland, the first confirmed customer, TrackX represents both a capability boost and a statement of national industrial strength within NATO. For allies, it is a reminder that innovation in mobility is once again a priority. The message from DSEI 2025 is clear: the TrackX is more than just a new vehicle. It is a symbol of renewed European focus on lightweight, adaptable solutions for modern warfare, and one that is already moving from prototype to reality. At DSEI 2025 in London, Milrem Robotics and Moog presented one of the most striking demonstrations of the exhibition, a fusion of unmanned ground mobility and short-range air defense. Their joint solution showcased the combat-proven Themis unmanned ground vehicle equipped with Moog's flexible mission platform and Thales missile systems, effectively turning a support UGV into an autonomous counter system. The Themis, already well known for its modularity and use in frontline logistics and support, was displayed in a new configuration featuring a 4-cell launcher for FIM-92 Stinger missiles. This places the vehicle firmly within the Mobile Short-Range Air Defense (MSHORAD) concept, a capability already deployed on manned vehicles like the U.S. Stryker A-1, but now adapted to a smaller, unmanned, and expendable format. The design is highly modular. The Moog flexible mission platform allows rapid integration of guided weapons, while the Themis chassis ensures mobility across challenging terrain. By combining these with combat-proven Stinger technology, the system delivers a scalable, mobile, and crew-free solution against threats like drones, helicopters, and low-flying aircraft. At a time when unmanned aerial systems are multiplying on battlefields from Ukraine to the Middle East, this innovation addresses a critical vulnerability for NATO and allied forces. From a technical standpoint, the concept offers several advantages. The UGV's track design allows it to go where wheeled vehicles cannot, providing persistent protection in high-risk areas. Operating without a crew reduces exposure to enemy fire, while its relatively small size and reduced signature make it harder to detect. In essence, the system provides gap-filling coverage for traditional air defense networks, creating layers of survivability and redundancy. Operationally, the Themis platform is already combat-proven, having been deployed in Ukraine for transport and casualty evacuation. This background strengthens the credibility of its new air defense role. By integrating the same missile types as manned systems, it ensures compatibility with existing doctrines while offering a distributed, expendable alternative that can be fielded in larger numbers. Strategically, this integration reflects a broader shift in defense thinking. Modern conflicts have highlighted how swarms of cheap drones can overwhelm conventional defenses. An unmanned, modular, and easily deployable air defense system allows armies to respond flexibly, protecting forward units without tying down larger, more expensive assets. It also signals a growing industrial trend, using legacy weapons in new autonomous frameworks, stretching their relevance while investing in robotic innovation. The presence of Milrem Robotics and Moog at DSEI 2025 underscores how autonomy and modularity are becoming pillars of future land warfare. The message is clear: air defense is no longer just about big systems on heavy platforms. It is about distributed, robotic solutions that can move fast, adapt quickly, and survive in contested environments. With the THMIS-based air defense system, Milrem and Moog are not only offering a new product, but also presenting a concept for the battlefield of tomorrow, where autonomy and protection go hand in hand. At DSEI 2025 in London, Turkey's defense giant Aselsan unveiled the Korkut 100/25SB, a next-generation mobile counter-UAV system aimed at meeting the growing threat posed by mini and micro drones on modern battlefields. With unmanned aerial systems increasingly employed for reconnaissance and strike missions, effective close-range air defense has become a strategic necessity. Aselsan's new system combines mobility, precision, and layered countermeasures, setting a new benchmark for tactical drone defense. The Korkut 125SB employs a dual soft-kill and hard-kill approach. Advanced radar and electro-optical sensors detect and track threats in real time, while a remotely operated stabilized turret delivers lethal fire with Aselsan's 25mm Atom Airburst smart ammunition. Programmable rounds explode near low-signature targets, ensuring high lethality even against coordinated drone swarms. The system's effective range exceeds 1,000 meters, supplemented by a coaxial 7.62mm machine gun for additional defense against ground or airborne threats. Automation plays a central role. AI-powered algorithms enable rapid detection, classification, and engagement, reducing operator workload and increasing reaction speed. Electro-optical payloads, including high-resolution day and thermal cameras and a laser rangefinder, provide all-weather, day and night coverage. AESA radar integration enhances detection, while the modular design allows installation on various armored wheeled platforms, giving armed forces flexibility for deployment across diverse environments. Operationally, the Korkut 125SB can engage threats on the move or from stationary positions, with turret elevation ranging from -20 to +70 degrees and firing rates up to 600 rounds per minute. Beyond kinetic solutions, the system incorporates RF countermeasures for soft kill disruption of hostile drones' navigation and communications. This layered design effectively bridges the gap between small arms and missile-based air defense. Strategically, Aselsan's system addresses the realities of contemporary conflicts. Experiences from Ukraine and the Middle East have shown that commercial and military drones can disrupt logistics, target frontline units, and saturate defenses. With mobility, modularity, and on-the-move engagement, Korkut 100/25SB protects convoys, command posts, and forward bases, offering both tactical and geopolitical value. The system also reflects Aselsan's broader commitment to innovation. By expanding the Korkut family beyond its original self-propelled anti-aircraft gun design, the company is responding to emerging aerial threats with a cost-effective yet potent solution. The DSEI unveiling signals not only technological advancement but also Turkey's growing role in shaping global defense capabilities. As Aselsan President Ahmet Akyol emphasized, the Korkut 125SB sets a new standard for tactical drone defense on the modern battlefield, combining mobility, precision, and integrated counter-UAV technology. With this system, Aselsan delivers a platform ready for the challenges of modern warfare, where drones are reshaping battlefield dynamics. At DSEI 2025, General Dynamics showcased a striking example of modern land fire support innovation, a militarized Ford Ranger Super Duty equipped with the ground-deployed Advanced Mortar System, DAMS. This platform highlights a growing trend in defense, the conversion of commercial vehicles into tactical, multi-role assets capable of providing indirect fire, command, and combat support. The DAMS system, developed by ST Engineering Land Systems and distributed in Europe by Babcock, is notable for its lightweight, rapidly deployable design. It can transition from stowed to operational in just 15 seconds, enabling highly mobile units to deliver firepower quickly without relying on heavy armored platforms. Compatible with 81mm and 120mm ammunition, including precision-guided rounds, the system ensures continuity with existing stocks while expanding tactical options. Short-fire missions allow up to 15 rounds per minute, while sustained operations reach 4 rounds per minute, providing flexibility for different battlefield scenarios. Mounted on a Ford Ranger, the system benefits from the vehicle's 2,000 kg payload capacity and reconfigured interior. Using a widely available civilian chassis offers practical advantages, easier access to spare parts, lower unit costs, and simplified maintenance throughout the vehicle's lifecycle. The integration of a fully digitalized fire control system allows automatic laying using target coordinates from a command post, minimizing response time and exposure to enemy counterfire. A patented blast diffuser reduces crew noise exposure threefold, enhancing survivability and stealth during operations. From an operational perspective, this approach reflects lessons learned from current conflicts, including the war in Ukraine. Modern armies increasingly favor mobile mortar capabilities that can support fast-moving units rather than slow, traditional formations. Vehicle-mounted mortars like DAMS allow teams to shoot, relocate, and conceal themselves rapidly, reducing vulnerability to counter-battery strikes. Mobility, concealment, and speed are emerging as decisive factors in contemporary artillery doctrine. Strategically, the DAMS-equipped Ranger demonstrates a practical balance between firepower and flexibility. It can serve in a variety of roles, from logistics and troop support to direct fire missions, without requiring specialized, costly platforms. This aligns with broader trends in European and NATO forces, which emphasize cost-effective, adaptable systems that respond to evolving battlefield realities. By combining a proven mortar system with a commercially available, rugged chassis, General Dynamics, ST Engineering, and Babcock illustrate how modular, mobile, and rapidly deployable solutions are reshaping indirect fire support. At DSEI 2025, the DAMS Ranger represents more than a weapon, it embodies a philosophy of speed, survivability, and operational adaptability for modern land warfare. At DSEI 2025 in London, Belgian manufacturer FN Herstal unveiled its latest innovation in small arms, the Evolys ultralight machine gun, designed in both 5.56 by 45 mm and 7.62 by 51 mm NATO calibers. The weapon responds to a critical need in modern operations, combining the sustained firepower of a belt-fed machine gun with the mobility and ergonomics of an assault rifle. Weighing just 5.5 kilograms in 5.56 millimeters and slightly over 6.2 kilograms in 7.62 millimeters, the Evolys is nearly a third lighter than legacy systems such as the Minimi. This weight reduction allows soldiers to carry more ammunition, move faster, and maintain suppressive fire with less fatigue. A patented side-opening feed tray enables continuous use of optics on a single uninterrupted top rail, solving a long-standing problem of zero shift during reloads. A key innovation is the hybrid firing mode. The weapon can switch between sustained automatic fire and semi-automatic precision, providing flexibility for both suppressive fire and controlled engagements. Optimized for suppressor use, the Evolys features reinforced gas regulation and tailored muzzle devices to reduce sound and flash, critical for special operations and counter-terrorism missions. Ergonomics have been central to the design. Fully ambidextrous controls, an adjustable folding stock, multiple MLOK interfaces, and mirrored charging handles and fire selectors accommodate both left and right-handed operators. A tool-free quick-change barrel system supports prolonged engagements, while advanced polymers and additive manufacturing reduce weight without compromising durability. For infantry units, the Evolys offers greater tactical flexibility. Lightweight and maneuverable, it is suitable for urban combat, mountainous terrain, or dense forests, enabling squads to carry high-volume firepower without sacrificing mobility. Integration with suppressors, advanced optics, and battlefield networks ensures readiness in modern, connected combat environments. Special forces also benefit from the system's agility and adaptability. Whether during air assault insertions, maritime boarding, or close-quarter raids, Evolys allows operators to rapidly transition between suppressive automatic fire and precise semi-automatic engagement. Reduced weight supports long-duration missions, lowering fatigue and increasing endurance in high-intensity operations. The program addresses a long-standing capability gap. Infantry squads have historically had to choose between lighter 5.56 mm weapons with limited range and heavier 7.62 mm platforms that hinder mobility. By offering ultralight designs in both calibers, Evolys enables commanders to tailor squad firepower to mission requirements. The 7.62 mm variant provides long-range suppression and higher lethality without the burdens of traditional machine guns. By merging precision, fire volume, and soldier-centric ergonomics, the Evolys represents a significant evolution in light machine gun design. FN Herstal's new weapon reflects the operational demands of 21st-century conflict, where infantry units must remain highly mobile yet lethally capable, and special forces require adaptable weapons across a spectrum of modern warfare scenarios. At DSEI 2025 in London, German defense company Rheinmetall unveiled the Fuchs JAGM, a next-generation mobile tank destroyer developed in partnership with U.S. Lockheed Martin. The system integrates precision air-to-ground missiles into the modernized 6x6 Fuchs Evolution armored vehicle, providing multi-domain strike capability on a tactical wheeled platform for the first time. The Fuchs JAGM features a 24-cell vertical launch system, capable of firing both AGM-179 JAGM and AGM-114L Hellfire longbow missiles against ground and aerial targets. This enables the vehicle to engage main battle tanks, infantry fighting vehicles, low-flying helicopters, drones, radar stations, mobile artillery, bunkers, and lightly armored naval assets. With no need to reload between salvos, the system provides rapid response against multiple threats. The AGM-179 JAGM combines semi-active laser guidance with fire-and-forget millimeter-wave radar, offering high accuracy against moving and stationary targets in all weather conditions. Its tandem-shaped charge warhead can defeat reactive armor while delivering fragmentation effects on soft targets. The Hellfire longbow variant employs active radar homing for fire-and-forget capability, making it highly effective against moving armored vehicles and low-flying aircraft even in adverse conditions. Both missile types are housed in the Fuchs vertical launch module, allowing for sequential fire and autonomous engagement cycles. The Fuchs Evolution chassis represents a modernized upgrade of Rheinmetall's legacy 6x6 Fuchs APC, used in over 9 countries since the Cold War. Enhancements include a new powertrain, anti-lock brakes, a central tire inflation system, and compliance with NATO generic vehicle architecture standards for plug-and-play integration of mission systems. Cruise survivability is prioritized with upgraded ballistic protection, CBRN shielding, and ample internal space for mission equipment and missile modules. Advanced digital architecture supports command, control, diagnostics, and interactive fleet maintenance. From an operational perspective, the Fuchs JAGM introduces a new paradigm in mobile strike capability. Unlike conventional anti-tank guided missile vehicles or short-range air defense systems, it allows ground forces to execute deep strikes, ambush armored columns, and rapidly respond to aerial threats without relying on fixed launchers or air support. The combination of long-range precision firepower with mobility and protection makes the system suitable for contested environments and peer-level conflicts. Strategically, the unveiling is timely. NATO nations are reassessing force posture in light of renewed peer threats and contested mobility corridors. The Fuchs JAGM offers a versatile, agile, and network strike solution, bridging gaps between traditional anti-armor assets and emerging multi-domain warfare requirements. Its introduction at DSEI 2025 signals a push toward vehicles capable of independent, rapid response precision engagements, a significant step in European and Allied land warfare modernization. By integrating proven U.S. missiles with a modern German armored platform, Rheinmetall and Lockheed Martin demonstrate the potential of international collaboration in developing next-generation battlefield solutions capable of redefining tactical engagements against both ground and air threats. At DSEI 2025 in London, French company Exosens unveiled its latest innovation in night vision technology, the 5G Image Intensifier Tube. Presented as the most advanced night vision tube on the market, the 5G promises to redefine standards for modern armed forces, offering enhanced detection, sharper imaging, and reduced operator fatigue. Several Special Forces units had already placed orders prior to the public debut, underlining its operational relevance. The 5G tube represents a leap in performance compared to its predecessors. With a figure of merit (FOM) of 2,500, it surpasses the 4G, 1,800, and 4G+, 2,300, models, delivering up to 35% greater detection range while minimizing noise and flicker. Operators benefit from sharper images, improved perception of textures and contrasts, and a notable reduction in cognitive load. These enhancements are critical for both reconnaissance and combat scenarios, where rapid identification of threats in darkness can determine survival and mission success. Exosens emphasizes flexibility and user integration. The 5G tube is compatible with monocular and binocular mounts, as well as with older generation devices, allowing armies to upgrade without fully replacing existing equipment. Applications include standard night vision goggles, helicopter piloting at night, and integration into wide field of view systems exceeding 50 degrees, where the tube increases the usable image area by more than 70%. This versatility ensures the tube meets a broad spectrum of operational needs across land, air, and special operations forces. The company's industrial strength underpins the 5G's production. With 120,000 units per year and around 2,500 tubes per week, Exosens maintains full control over its manufacturing chain, ensuring precision and quality. Notably, the 5G is ITAR-free, containing no American components, guaranteeing sovereignty for European clients, a significant factor as NATO members accelerate rearmament. Strategically, the 5G tube positions Exosens as a key player in global night vision. The technology allows soldiers to see farther and more clearly at night, enhancing situational awareness, reducing risk, and increasing operational effectiveness. In modern conflicts, where darkness and low visibility can be decisive, superior night vision provides both tactical and survival advantages. Exosens' ambition extends beyond Europe. While the company already supplies almost all European armies, it now aims to penetrate the U.S. market, competing with established American manufacturers. Success in this arena would cement Exosens' status as a global leader in night vision, demonstrating the strategic impact of European innovation on modern defense capabilities. With the 5G tube, Exosens not only delivers technological advancement but also enhances soldier safety, operational effectiveness, and battlefield awareness, marking a decisive step forward in the evolution of night vision for 21st-century warfare. At DSEI 2025, Pearson Engineering showcased its RCV-Pioneer equipped with the minefield breaching mission payload, highlighting the growing integration of robotics into combat engineering operations. This configuration demonstrates how a single robotic platform can be rapidly adapted for specialized tasks via modular payloads, enabling armed forces to address evolving threats in the field. The RCV-Pioneer is designed as a pre-configured, self-contained robotic vehicle capable of hosting a variety of engineering tools. In its minefield breaching role, the system attaches payload specifically for clearing safe lanes through minefields and explosive obstacles. Modules can be integrated or removed using a self-lifting mechanism, allowing the vehicle to position itself beneath the payload for attachment. Quick-release fastenings enable two operators to complete the process in approximately 30 minutes, without the need for specialized tools. Autonomy is a key feature. The payload does not rely on hydraulic power from the host vehicle and can operate using electrical power from the robot or generate its own through an integrated diesel engine. Remote operation is handled via an operator station with joysticks and touchscreen, incorporating camera feeds for situational awareness. The system is also designed to allow future upgrades toward higher autonomy, paving the way for automated combat support functions. The RCV-Pioneer builds on Pearson's experience in robotic engineering, tested previously with a prototype combining obstacle clearance payloads and manipulators capable of lifting up to 500 kilograms. Features such as V-shaped dozer blades, mine-clearing line charge, MICLIC, frames, and flexible load areas demonstrate the platform's modularity and adaptability to different mission requirements. The operational relevance of robotic mine clearance is clear in contemporary conflicts, including the war in Ukraine. Extensive deployment of anti-tank mines, improvised explosive devices, and other explosive hazards restrict maneuverability, endanger troops, and complicate the movement of armored formations. Systems like the RCV-Pioneer allow combat engineers to secure safe lanes, neutralize explosive threats, and maintain operational momentum, while reducing risk to personnel. Beyond battlefield applications, robotic demining contributes to humanitarian outcomes, clearing land for civilian use, enabling the return of displaced populations, and supporting economic recovery in post-conflict regions. The combination of modularity, autonomous power, and remote operation makes the RCV-Pioneer not only an operational asset but also a tool that supports stability and reconstruction efforts. For nearly 40 years, Pearson Engineering has developed equipment to enhance mobility, protection, and combat engineering capabilities. The RCV-Pioneer represents a natural evolution of these technologies, extending modular, mission-adaptable payloads to unmanned systems. Its presentation at DSEI 2025 underscores the increasing role of robotics in modern combat support, and its deployment is expected to expand as armed forces accelerate the integration of unmanned platforms for specialized operations. By combining flexibility, automation, and operational safety, the RCV-Pioneer demonstrates how robotics is reshaping combat engineering, providing forces with advanced tools to operate in hazardous environments while reducing risk to personnel. At DSEI 2025 in London, the British Army showcased the Challenger 3, the latest and most advanced iteration of its main battle tank, signaling a major upgrade in the UK's armoured warfare capabilities. Developed by Rheinmetall BAE Systems Land, RBSL, the Challenger 3 represents a deep modernization of the Challenger 2 platform, combining enhanced protection, advanced digital systems, and NATO standard lethality into a future-proof main battle tank. The most notable upgrades include a completely redesigned modular armor package, offering superior defense against tandem charge warheads, top attack munitions, and kinetic energy rounds. Complementing this passive protection is the integration of the Rafael Trophy Active Protection System, providing 360-degree detection and interception of incoming anti-tank guided missiles and RPGs. Together, these systems ensure the tank's survivability against the growing range of modern anti-armor threats. The Challenger 3 retains the Rheinmetall L55A1 120mm smoothbore gun, capable of firing advanced programmable munitions such as the DM-73, achieving engagement ranges exceeding 5,000 meters. Its turret integrates next-generation electro-optical sensors and a fully digital fire control system, enabling high-speed target acquisition and precision engagement in all weather and visibility conditions. A new hydrogas suspension enhances cross-country mobility and firing stability, while a digital architecture supports AI-enhanced systems, C4ISR integration, and seamless networking with NATO forces. Crew survivability and operational efficiency are prioritized with fully digitized workstations, panoramic commander sights, independent gunner thermal imaging, automated target tracking, and health monitoring for vehicle subsystems. These features enable true hunter-killer capability, allowing crews to detect, track, and engage multiple targets quickly in high-intensity operations. Under an £800 million contract, 148 Challenger 2 tanks will be upgraded to the Challenger 3 standard, with initial operating capability expected by 2027 and full deployment by 2030. 8 prototypes are currently in various testing stages, including live-fire assessments and factory trials, confirming the performance of the gun system, turret, engine integration, and electronic subsystems. When compared with Western counterparts, Challenger 3 offers a unique balance of heavy armor, lethality, and future-proofing. Against the Leopard 2A8, it matches gun performance but differentiates through bespoke British suspension and modular armor. Compared with the Turkish Altay, it excels in battlefield maturity, sensor integration, and active protection. Relative to the M1A2 Abrams SEPV-3, Challenger 3 achieves parity in digital architecture and survivability while potentially offering logistical advantages in European operations due to its diesel engine. Strategically, Challenger 3 is not only a combat vehicle but a platform designed for iterative upgrades into the 2040s, ensuring that the British Army maintains credible armor deterrence in a high-end conflict environment. By integrating advanced protection, lethality, and digital systems, Challenger 3 positions the UK as a leading NATO contributor in armored warfare and represents a forward-looking approach to modern battlefield dominance. At DSEI 2025 in London, BAE Systems UK presented STRIX, a next-generation uncrewed air system designed to combine precision strike capabilities with extended intelligence, surveillance, and reconnaissance (ISR) functions. Originating as a joint project between BAE Systems Australia and Innovero, STRX represents a versatile vertical takeoff and landing (VTOL) platform capable of operating in constrained environments, from ships and helicopters to austere forward locations. STRIX features a hybrid tandem wing design, enabling both precision air-to-ground attacks and ISR missions. Its VTOL capability allows rapid deployment without runways, while its hybrid electric propulsion provides flexibility between hovering and fixed-wing flight. The drone can carry up to 160 kilograms of payload over 800 kilometers, and its compact footprint of 2.6 by 4.5 meters enables transport in standard 20-foot containers. Operational service could be achieved as early as 2026, with a prototype already in development. A key component of the STRX system is its integration with the RAZER precision-guided munition, a low-cost modular kit designed to convert conventional 40 to 50 kilograms bombs into guided weapons. This combination allows STRX to deliver effective strikes while filling the capability gap between inexpensive, short-range systems and costly, long-range air-launched munitions. The modularity and affordability of this system offer military planners flexibility in both tactical deployment and procurement strategies. Beyond its tactical applications, STRX is designed to act as a loyal wingman, supporting helicopters and manned aircraft by providing ISR coverage or direct strike support. Its system architecture allows rapid adaptation for different missions, including surveillance, strike, and aircrew protection, reflecting the growing trend toward multi-role uncrewed systems in modern militaries. Strategically, STRX reinforces Australia's defence industrial sovereignty. By leveraging domestic aerospace expertise and involving small and medium-sized enterprises alongside academia, the program strengthens local defence capabilities while ensuring scalable production. Its development also highlights international collaboration, as BAE Systems leverages experience from other autonomous programs such as the MQ-28 Ghost Bat and M113 automation systems. The unveiling of STRX at DSEI illustrates the broader shift in military doctrines toward integrated, modular, and autonomous platforms. By merging ISR and strike capabilities in a compact, transportable VTOL drone, BAE Systems demonstrates how emerging uncrewed systems are set to redefine battlefield dynamics, enabling forces to conduct precision operations with reduced risk to personnel. STRIX and RAZER exemplify a new generation of adaptable combat solutions, bridging the gap between tactical flexibility, affordability, and technological sophistication. At DSEI 2025 in London, HDT Global presented the Hunter Wolf, a hybrid 6x6 unmanned ground vehicle, UGV, designed to enhance infantry operations through mobility, endurance, and modular support capabilities. The platform reflects the increasing role of robotics in modern land warfare, addressing operational challenges such as logistics, casualty evacuation, ISR, and combat support in complex or high-threat environments. The Hunter Wolf combines a diesel/JP-8 engine with electric propulsion, enabling both silent operations and extended range. Fully fueled, the UGV can travel over 300 kilometers, with optional long-range tanks extending this to more than 1,000 kilometers. In silent electric mode, it covers 12 kilometers off-road, making it suitable for reconnaissance and covert maneuvers. Capable of carrying up to 1,000 kilograms of payload and exporting 15 kilowatts of power, the Wolf can support forward operating bases, radar systems, electronic warfare suites, or medical equipment directly in the field. Its rugged design, including Michelin non-pneumatic wheels, allows it to climb 60% slopes and ford water up to 60 centimeters, ensuring operational flexibility in diverse terrains. Modularity is central to the Wolf's value. The vehicle can be fitted with a variety of mission kits, including CBRN detection, water purification, expeditionary bridging, mine-clearing flails, battering rams, or remote weapon stations ranging from M2 machine guns to 30mm turrets. For medical missions, it can carry up to 4 liters for casualty evacuation. Its compatibility with open-source ROS autonomy kits enables semi-autonomous navigation, obstacle avoidance, and mission execution. Operationally, the Hunter Wolf acts as a force multiplier. By transporting equipment and munitions across difficult terrain, it reduces physical burdens on soldiers and extends combat endurance. Its ability to deliver electrical power in theater supports sustained operations of UAVs, communications, and electronic attack systems. In contested or high-risk missions, unmanned operation minimizes risk to personnel, while the silent electric drive reduces acoustic and thermal signatures, enhancing survivability. Strategically, the Hunter Wolf addresses emerging battlefield requirements highlighted by recent conflicts in Ukraine, where unmanned systems have proven essential for logistics, reconnaissance, and engineering under fire. NATO's focus on multi-domain operations and dispersed force structures underscores the importance of modular, autonomous vehicles that can integrate across coalition forces. By combining mobility, endurance, and power projection, the Hunter Wolf positions itself as a next-generation platform capable of supporting both current and future expeditionary operations. The DSEI 2025 unveiling demonstrates how HDT Global is aligning industrial innovation with operational necessity, offering a versatile, resilient, and strategically relevant UGV that reflects the growing integration of unmanned systems into modern land warfare. At DSEI 2025 in London, General Dynamics UK officially unveiled the Infantry Fighting Vehicle, IFV, variant of the Ajax family, marking the most significant expansion of the program since its inception. Built on the extended Ares hull, this new configuration increases internal volume to accommodate additional troops and heavier combat systems, creating a fully modern platform for mechanized infantry operations. Central to the IFV's combat effectiveness is its uncrewed turret, developed by Lockheed Martin UK, equipped with the 40mm case telescoped armament (CTA) system and an integrated Javelin anti-tank missile pod. This combination enables engagement of both infantry and armored threats at extended ranges. Survivability is enhanced through the modular integrated protection system, paired with Iron Fist active interceptors to counter incoming projectiles. Mobility improvements include composite rubber tracks, which reduce vibration and noise while maintaining cross-country performance. The rear compartment accommodates 8 dismounts, establishing the Ajax IFV as the first true infantry fighting vehicle in the family. The Ajax family was designed as a transformational program for the British Army, bridging the gap between heavier platforms like the Challenger 2 and lighter-wheeled systems such as Boxer. Prior variants, Reconnaissance, Ajax, Specialist Troop Carrier, Ares, Command and Control, Athena, Engineering Reconnaissance, Argus, and Recovery/Repair, Atlas and Apollo, focus on battlefield support. The new IFV introduces direct combat capability, addressing a gap left by the gradual retirement of the Warrior IFV. A key feature of the IFV program is recycling technologies from prior initiatives. The 40mm CTA gun and turret development from the cancelled Warrior Capability Sustainment Program, WCSP, are repurposed here, preserving industrial investment while delivering a modernized solution. Industrial responsibility is shared between General Dynamics UK as the prime contractor and Lockheed Martin UK for the turret, supporting the domestic defence sector. In a European context, the Ajax IFV competes with Rheinmetall's KF-41 Lynx, Ascot, and Boxer IFVs. Its advantage lies in a common tracked architecture across reconnaissance, command, engineering, and infantry fighting roles, simplifying logistics, training, and maintenance. Early training has already begun on Ajax platforms, with the Household Cavalry Regiment slated as the first operational unit. Full integration across British mechanized brigades is expected to follow in subsequent years. The Ajax IFV exemplifies a modular, future-proofed approach to mechanized infantry warfare. By merging firepower, protection, and troop transport in a single-tracked platform, it enhances the British Army's ability to conduct high-intensity operations while maintaining operational flexibility. With its combination of modern systems and reusable technologies, the Ajax IFV positions the UK at the forefront of medium-weight armoured vehicle innovation, while also offering potential for international export. At DSEI 2025 in London, QinetiQ showcased an advanced configuration of its Banshee Jet80 Plus aerial target drone, now integrated with a Rattler supersonic target missile mounted beneath its fuselage. This combination underscores the growing emphasis on realistic supersonic threat simulation, vital for preparing modern air defense systems to counter next-generation missile technologies. The Banshee Jet80 Plus is a long-established aerial target platform capable of speeds up to 200 meters per second, altitudes of 10,000 meters, and executing dynamic maneuvers up to 4G. With over 40 minutes of endurance, the system allows operators to conduct extended exercises, testing radar tracking, interception protocols, and engagement procedures under realistic operational conditions. Its widespread adoption confirms its role as a proven, reliable training solution across multiple armed forces. The addition of the Rattler supersonic target missile introduces a new level of challenge. The missile can exceed Mach 1.8, and over Mach 2.5 in the Rattler GAL-ST variant, simulating both air-launched and ground-launched supersonic threats. Capable of corkscrew and weaving maneuvers, the missile pushes air defense crews to react to highly demanding target profiles, replicating the performance characteristics of modern adversary weapons. By mounting the Rattler under the Banshee Jet80 Plus, QinetiQ offers a scalable, cost-effective solution for supersonic training without requiring live missile firings. Compared with other supersonic training systems, the Rattler strikes a balance between performance, flexibility, and affordability. Its aerospace-grade aluminum alloy construction ensures durability, while its environmentally safe design minimizes hazards post-mission. Real-time telemetry and positioning data enable operators to evaluate engagement effectiveness at every stage. Strategically, this combination reflects NATO and partner nations' growing urgency to prepare for supersonic and hypersonic threats. As potential adversaries invest heavily in next-generation missiles capable of overwhelming traditional defenses, realistic training platforms like the Banshee Jet80 Plus with Rattler are becoming indispensable. Beyond national defense exercises, the system supports multinational training operations, enhancing allied interoperability in air defense. By pairing the endurance and maneuverability of the Banshee Jet80 Plus with the high-speed threat replication of Rattler, QinetiQ provides a critical tool bridging current capabilities with the demands of tomorrow's aerial battlefield. The DSEI 2025 demonstration highlighted that future air defense readiness relies not only on interceptor systems but also on advanced, realistic training platforms, ensuring personnel are prepared for the most challenging operational environments. At DSEI 2025 in London, BAE Systems unveiled its latest autonomous underwater system, the Hearn XLAUV, extra-large autonomous underwater vehicle, representing a significant step forward in naval robotics and multi-mission underwater capability. Designed to meet the modern operational needs of navies, the Hearn XLAUV combines extended endurance, modular payload architecture, and deep operational versatility to support anti-submarine warfare, coastal defense, and intelligence, surveillance, and reconnaissance, ISR, missions. The Hearn XLAUV is capable of operating continuously for up to 45 days and covering ranges of 5,000 kilometers, while reaching operational depths of up to 5,000 meters. Its modular design enables rapid integration of mission-specific payloads, including advanced sonar systems, remotely operated vehicles, countermeasures, and weapon modules. This adaptability ensures that a single platform can perform multiple roles without requiring significant reconfiguration or additional platforms. Central to Hearn's capabilities is its autonomy system based on Nautomate, which manages navigation, mission planning, and payload deployment. This system allows the vehicle to conduct complex missions with minimal human intervention, while secure communications enable real-time data transmission across naval networks. Acoustic signature management minimizes detectability, ensuring operational stealth in contested maritime environments. From a technical perspective, the Hearn XLAUV is containerized for transport, fitting into a standard 40-foot shipping container, simplifying strategic deployment and logistics. Propulsion is powered by advanced batteries, with an option for hydrogen fuel cells to extend endurance further. Modular internal compartments allow for flexible payload configurations, including underhull deployment of sensors or armaments. Launch and recovery can be performed from a port, surface ship, or submarine, enhancing operational flexibility and reducing the risk to crewed vessels. The platform's development has been accelerated through international collaboration. BAE Systems partnered with Canadian company Cellular Robotics, producing an operational prototype in just 11 months. Trials in UK waters in 2024 validated Hearn's autonomous intelligence gathering capabilities, and the companies have since signed a 10-year strategic partnership to continue development and delivery. The Hearn XLAUV reflects a broader trend toward autonomous maritime systems, offering navies the ability to extend underwater coverage, reduce personnel exposure, and perform missions that would otherwise be too dangerous or resource-intensive. By combining endurance, modularity, and autonomous intelligence, the Hearn XLAUV positions the British Navy at the forefront of next-generation underwater warfare, bridging the gap between traditional crewed submarines and unmanned maritime platforms. At DSEI 2025 in London, Leonardo UK showcased the Proteus unmanned rotorcraft, a modular technology demonstrator designed to advance the Royal Navy's anti-submarine warfare, ASW, and multi-role maritime capabilities. Developed under the UK Ministry of Defence's Rotary Wing Uncrewed Air System, RWAS, program, Proteus reflects a strategic investment of £60 million aimed at testing and validating a fully autonomous naval rotorcraft within a 4-year Phase 3A plan. Proteus has an estimated maximum takeoff weight of 3 tons, drawing on the proven architecture of the Copter AW09 light helicopter, including its 4-bladed main rotor and shrouded anti-torque system. The aircraft's fuselage has been re-engineered for unmanned operations, optimizing internal volume for a modular payload bay capable of carrying up to 1,000 kilograms, equivalent to 2 NATO standard pallets. This modularity allows configuration flexibility. For ASW operations, the aircraft can deploy multi-static sonobuoys, while for logistics missions, payloads can be adjusted to maximize endurance and range. The platform relies on advanced composites and additive manufacturing, reducing structural weight and production costs. A digital twin, paired with AI-based control software, allows virtual testing of complex behaviors, including autonomous deck landings and mission execution, significantly shortening development cycles while reducing risk. Ground-based testing at Leonardo's Yeovil facility is nearly complete, with a maiden flight anticipated between the second and third quarters of 2025, followed by extensive trials in maritime environments. Proteus is designed for a broad spectrum of missions. Its primary role in ASW extends the reach of surface combatant sonar coverage without risking manned helicopters. ISR, Airborne Early Warning, AEW, and logistics resupply are also supported, leveraging the aircraft's over 1,000 kg payload capacity and autonomous operations. Sensor integration includes electro-optical systems, radar, and AIS receivers, enabling real-time data transmission and enhanced situational awareness. In the global context, Proteus occupies a heavier and more flexible class than comparable platforms such as the US MQ-8C Fire Scout or Airbus VSR 700, combining payload capacity, endurance, and modularity to support multi-role naval operations alongside manned helicopters. The system directly addresses the Royal Navy's priorities, including countering Russian submarine activity in the North Atlantic and supporting the ASW Spearhead initiative, while offering export potential to NATO and partner nations. By merging helicopter heritage with unmanned autonomy, Proteus exemplifies the next generation of naval aviation. Its introduction promises enhanced operational tempo, reduced risk to personnel, and a cost-effective method to expand maritime surveillance, ASW, and logistics capabilities. Leonardo's program also strengthens the UK's aerospace engineering base, positioning the country as a leader in heavy-class unmanned rotorcraft for naval operations.